Question 2 is coming from Quadratics. A curve has equation, this one here, and a straight line has this equation, where c is a constant. Find a set of values of c for which the curve and the line intersect at two distinct points. So first of all, we need to solve these two simultaneously. So for intersection, we are going to use substitution. So I'll have, in the place of y for this, I can put this whole thing here, okay? So we shall have x squared plus 2cx then plus 4, which is equal to 4x plus c. And then bring everything this side. We shall have x squared plus 2cx minus 4x, then plus 4 minus c, which is equal to 0. And then the quadratic equation that comes from these two is going to be x squared plus, I'll put 2c here minus 4, then x outside, okay? Then plus 4 minus c, which is equal to 0. So using the general equation, the general quadratic equation, ax squared plus bx, then plus c, which is equal to 0. Our a is the one here, the b is this one here, and then c is this whole constant here, you see? Then from there, we can have for two distinct points, points of intersection, b squared minus 4ac has to be greater than 0. Remember, when we are solving the quadratic equation using the quadratic formula, we have x is equal to minus b plus or minus to the root of b squared minus 4ac. So this discriminant b squared minus 4ac is the one that determines the number of roots and their nature that you get. So if this one is greater than 0, that means when you are finding the roots, you are going to consider the plus and then the minus. That is why you are getting those two. You get it? If this one here is positive, you are getting those two. Okay? But if it is equal to 0, then this whole thing disappears. In other words, you are going to have one repeated root, which is minus b over 2a. Okay? And then, if it is less than 0, then you cannot get the square root of a negative unless you are in complex numbers. So the roots are not real. They are complex. So for that case, then we say less than what? 0. That means the line and the curve do not intersect. You see that? Okay. Now, let us look at this one here. B squared. Our b is 2c minus 4. We square it, minus 4. Our a is a 1, a silent 1 here. And then c is 4 minus c greater than 0. So to expand this one, get this 2, then square this one. You will have 4c squared, then 2 times 2c times negative 4. That one will give us negative 16 of c, and then put this square on the 4, which gives us a positive 16. Then minus this 4, of course, times 4, that one will give us 16. And then minus 4, then times minus c. So that will be a positive 4c greater than 0. So you can see, of course, this 16 and this one going. And then we remain with 4c squared minus 16 plus 4c, we shall get negative 12. So we get negative 12c, which is greater than 0. I can actually factorize here. 4c is common, then I get c minus 3 here, which is greater than 0. A mistake that is done here is for people to say 4c is greater than 0, and also c minus 3 is also greater than 0. The way they solve quadratic equations, this is very wrong. So what you need to do here is to find the critical values. Okay, imagine you equate this one to 0, you will get your C as a 0. Then when you equate this one to 0, you will get your C as a 3. Now, we are supposed to look at the regions less than 0, in between 0 and 3, and then above 3. Now, due to the fact that the coefficient of C squared here is a positive and this is quadratic, then that means we are having a U-shaped curve. Okay? Then, where this one crosses the C axis, now it's not X because the quadratic is in terms of what? Of C. So I would say maybe this is C. Then here we are having 0, and then here we shall have 3. So this is the positive part of the graph because it is above the C axis, and then this is the negative because it is below, and then here it is also positive because it is above. Okay? Now, we are interested in the regions that are greater than 0, the positive ones. So we can see this one here and then this one here. So we conclude, therefore, that C is less than 0 and C is greater than 3. So that is the set of values for which that straight line intersects the curve at 2 distinct points.